Today we're diving into two important concepts in optics, spherical aberration and chromatic aberration. Alright, let's start with spherical aberration. Now imagine a simple convex lens. Normally we'd expect all the light rays passing through to meet at a single focal point, but what actually happens is that light rays hitting the edges of the lens bend more than the ones passing through the center. So instead of one sharp focus, we get multiple focal points, and the image ends up looking a little bit like blurry, right? Let me put up a drawing for this. See how the rays from the edges don't meet at the same place? That's what causes the blur, right? Now, this isn't just like a lens problem, right? It happens in spherical mirrors too. If you take a concave mirror, same issue, rays hitting the outer part focus at different points than the central rays. That's why image in certain mirrors can look distorted or soft. How to fix it? There are a few ways. One is using aspherical lenses, which are specifically shaped so that all light rays converge correctly. And another trick, especially in cameras, is reducing the aperture size, basically blocking out the outer rays so only the central part of the lens is used. Well, that helps a lot. So there's this thing called astigmatism. It's kind of like an uneven lens problem. Instead of light focusing at one sharp point, it gets stretched out in different directions. Imagine if a lens wasn't shaped even like instead of being nice and smooth, it's a little squished in one direction. That messes with how light bends. So instead of a clear focus, you get an image that's kind of blurry or stretched depending on where you're looking. And a lot of people have it. And really, the only way to fix it, you just kind of gotta wear glasses that correct the focus. Now let's talk about chromatic aberrations, which is a totally different problem. This one's all about color. When white light passes through a lens, different colors bend by different amounts because each wavelength has a slightly different refractive index. That means they don't all focus at the same point, and you end up with these weird color fringes around objects, especially in high contrast areas. Here's a simple way to picture it. See how the blue light focuses closer, while like red focuses farther. That's why you get those purple or green edges in some photos. You've probably seen this effect if you zoom in on a bright object in a photo and notice colored outlines. That's chromatic aberration in action. It happens in cameras, telescopes, even in our own eyes, like to some extent. How to fix it? The best solution is using achromatic or apochromatic lenses, which are made of multiple types of glass to cancel out the dispersion. That's why high-end cameras and telescopes use these special lens systems to keep images sharp and free of color, like fringing, right? Spherical aberration messes with focus, and chromatic aberration messes with color. Both are things optical engineers have to deal with when designing cameras, glasses, and even microscopes. Hope it all made sense, and I hope you found this useful and interesting. So thanks for watching, and I'll see you in the next one.